Myself, Dr. K. V. Raghavulu, working as Associate Professor in the Department of Mechanical Engineering, Marri Reddy Institute of Technology and Management. So today I would like to discuss a few concepts in Thermal Engineering 1. Actually, Thermal Engineering 1 and Thermal Engineering 2 are the applications of thermodynamics. So in thermodynamics, we discuss basic concepts. In Thermal Engineering 1 and Thermal Engineering 2, we will discuss in detail. So these are the my objectives of Thermal Engineering 1. So first, understand the basic components of IC engines and working of IC engines and combustion phenomenon in IC engines. Next, various cooling systems in IC engines, lubrication system in IC engines, and compressors. Next, compressors, working of compressors like reciprocating compressors or rotary compressors. Next, alternative, fuels. So these are the my objectives of this thermal engineering 1. Next, coming to the course outcomes, after completion of this course, so students will understand the main working of a IC engines and working of a compressors, then various performance characteristics of an engine, and how to calculate the heat balance sheet, how to calculate the efficiencies, and how to calculate the compressors efficiencies and working of alternate fuels. So all these things will be understanding after completion of this course. And this is the content of my today's lecture. So the main content, classification of engines, then engine parts and its working, then working of four-stroke engine, four-stroke diesel engine and petrol engine, then working of two-stroke petrol engine, and differences between SA and CA, and differences between two-stroke and four-stroke, wall timing diagrams, port timing diagrams, indicator diagrams. So this is the syllabus in module 1. Next, first topic is classification of IC engines. Actually, engine is a device which converts heat energy into the mechanical energy. Heat energy into the mechanical energy. So like that, engines, there are different types of engines. So engines are mainly classified, the first thing based on the fuel. We have a petrol engines and we have diesel engines. And based on the type of cycle, we have Otto cycle and diesel cycle and dual cycle. And based on the cylinders, we have a single cylinder engines, multi-cylinder engines. And based on the strokes, we have two-stroke engines and four-stroke engines. And based on the ignition systems, we have a spark ignition system and we have a compression ignition system, and based on the governing mechanism, based on the cooling mechanism, based on the lubrication system. So we have a different classification of IC engines. So today I'll discuss working of four-stroke petrol engine, diesel engine, and working of two-stroke petrol engine, and wall time diagrams, port time diagrams, and indicator diagrams. So this is the main engine and indicates various parts of an engine. So it consists of inlet. This is the inlet valve, and this is the exhaust valve. So mainly inlet valve is used to transfer the air from the atmosphere into the engine cylinder, and exhaust valve is used to deliver the exhaust gases from the engine cylinder to the atmosphere. And this is the spark plug. So it is a petrol engine, we have a spark plug. If it is a diesel engine, we have a fuel injector. So mainly spark plug is used to ignite the charge. And this is the engine cylinder. So here only main combustion takes place. So this is the piston. So piston, due to the combustion, piston hitting into the downward direction, then the piston moves top dead center to bottom dead center. So this is the reciprocating motion. So this is TDC, top dead center, and this is BDC, bottom dead center. So due to the combustion of the fuel, piston hitting into the downward direction, then it is moving into the upward direction and downward direction. So the piston is connected with the gut joint pin, and this gut joint pin is connected with the connecting rod, and connecting rod is connected with the crank pin, and crank pin is connected with the crank, and this is the crankshaft. So our main aim is to rotate the crankshaft. So here this reciprocating motion is converted into the rotary motion. So then after rotating the main shaft, then it is connected with a crankshaft, and that it is connected with the main shaft and vehicle, and moving the vehicle. So this is the top dead center and this is the bottom dead center, and this length is called as stroke length. And here we will maintain the clearance. This is called as a VC clearance, and this distance is called as this volume is called as a stroke volume. So these are the main parts of an engine. Then coming to the working of a 4-stroke diesel engine. Actually, 4 strokes means we have a suction stroke, compression stroke, expansion or power stroke, and exhaust stroke. In a suction stroke, so a suction stroke is also called as a intake stroke. So in a suction stroke, inlet valve is open and exhaust valve is closed. So if it is diesel engine, only air enters into the engine cylinder through inlet valve. Then the piston moves from TDC to BDC and it creates the partial vacuum. So that is the reason due to the pressure difference, the atmospheric air enters into the engine cylinder through inlet valve. So this is called as a suction stroke. So in a compression stroke, piston moves from BDC to this is BDC and this is TDC, top dead center. Piston moves from BDC to TDC. So in this stroke, both valves are closed, inlet valve and exhaust valves are closed. Then the air is compressed. Air is compressed. So at the end of the compression stroke, fuel is injected with the help of fuel injector. So this is called as a fuel injector. So here that self-ignition temperature of a diesel almost 260 to 270 degrees. So the temperature is maintained inside the engine cylinder due to the compression of the air. Then automatically combustion starts. So here no need of a spark plug. So the temperature already reached inside the engine cylinder. Then whenever injecting the fuel with the help of a fuel injector, then automatically combustion starts and burning the fuel at the end of the compression. So due to this burning of the fuel, it produces the hot gases. Then the piston hitting into the downward direction. Then that stroke is called as a power stroke or expansion stroke. So in this stroke, piston moves from TDC to BDC. Due to the explosion of the gases, this piston moves from TDC to BDC. So this stroke is also called as a power stroke. So because of this stroke only, energy is produced. So due to this energy, piston is moving from TDC to BDC. Then it rotates the crankshaft. So our main aim is to rotate the crankshaft. Then after completion of the power stroke, there is no use of these gases. So these gases should release from the engine. So at that time, our exhaust valve is open. Then the exhaust gases are going out from the engine cylinder to the atmosphere. So in this stroke, piston moves from BDC to TDC. This is BDC to TDC. Then piston moves from BDC to TDC like this. So here the pressure is greater than the atmospheric pressure. Then whenever opening the exhaust valve, then automatically gases are moving into the outward direction, atmosphere. So this is called as a working of a 4-stroke diesel engine. Then coming to the working of 4-stroke petrol engine. So the main difference is in a diesel engine, we uses the fuel injector. But here in a petrol engine, so air and fuel both are mixed in a carburetor before sending into the engine cylinder. So here only with the help of carburetor, that air and fuel both are mixing. Then that fuel is sending into the engine cylinder through inlet valve. So again, this 4-stroke petrol engine also consists of suction stroke, compression stroke, expansion stroke, and exhaust stroke. So this stroke, air and fuel are mixed in a carburetor, and whenever opening the inlet valve, so due to the pressure differences, this air and fuel mixer enters into the engine cylinder through inlet valve. So this is called as a suction stroke. Then in a compression stroke, piston moves from BDC to TDC. This is BDC to TDC. Then this charge, air and fuel mixture charge is compressed. So at the end of the compression stroke, with the help of spark plug, will ignite the fuel and burning the charge and produces the explosion. So then, due to this explosion, then the piston is hitting into the downward direction. Then this stroke is called as a expansion stroke. So in this expansion stroke, piston moves from TDC to BDC, and this stroke is also called as a power stroke. And then after completion of the power stroke, then there is no use on these gases. Then these gases are sending into the atmosphere through exhaust valve. So exhaust valve is open. Then the piston moves from TDC to BDC. Then BDC to TDC. Then these gases are sending into the atmosphere. So this is the difference between working of a four-stroke petrol engine and diesel engine. Strokes are same, valves mechanism also same. So these valves are operating with the help of a cam mechanism. So this thing also same. Only thing is in place of a fuel injector, we uses the spark plug for giving the for initiating the spark. Next, coming to the two-stroke engine. Generally, for a small capacity purpose, we uses the two-stroke engines. So two strokes means suction and compression. Suction and compression are completed in one stroke, and expansion and exhaust, these two are completed in one stroke. This is the meaning of two-stroke engine. So see, first one is a upward stroke. So in upward stroke, charge in a two-stroke engine, we have a ports instead of valves. So inlet, this is called as the inlet port, and this is called as a transfer port, inlet port, and this is called as exhaust port. So there are three ports in a two-stroke engine, and these are called as the fins. Generally, we uses the air-cooled engines in a two-stroke engine. So fins are used to exchanging the heat from the engine cylinder to the atmosphere. So in a two-stroke engine, we have three ports. So in upward stroke, the charge enters into the engine cylinder. So this is a petrol engine. So petrol engine means air and fuel are mixed in a carburetor. Then the charge enters into the a crankcase here. Then already previous charge is there in the cylinder. Then the charge is compressed. So now it is called as, this is suction and this is compression. So suction and compression, these two are completed in one stroke. That stroke is called as a upward stroke. Then in a downward stroke, then expansion and exhaust, these two are taking place in a downward stroke. So at the end of the compression stroke, this in upward stroke, then fuel is burning with the help of a spark plug. Then explosion takes place and produces the gases, and due to these gases, piston is moving into the downward direction, and this is called as a expansion stroke. And the gases, exhaust gases, are moving into the atmosphere through exhaust port. So this stroke is called as a downward stroke. So in upward stroke, suction and compression are completed, and in downward stroke, expansion and exhaust are completed. Generally, two-stroke engines are occupying very less space only for small capacity purposes only. We uses the two-stroke engines. Next, coming to the differences between SI engine and CI engine. Generally, in SI engines, we uses the petrol, and CI engines, we uses the diesel. And SI engines generally use spark plugs, and diesel engines we uses the fuel injector. Generally, for SI engines, compression ratio is very less, generally 8 to 12. And whereas in CI engines, the compression ratio is very high, almost 14:1 to 25:30:1. Then air fuel, both are mixed in a carburetor in a SI engine, and CI engine air fuel, only air enters into the engine cylinder, and at the end of the compression stroke, fuel is injected with the help of the fuel injector. So SA engine is operating with the help of Otto cycle. Generally, we uses the Otto cycle principle in SA engines. So in CA engines, we uses the diesel cycle principle. So Otto cycle means it consists of a isentropic compression, then constant volume heat addition, then isentropic expansion, and constant volume heat rejection in Otto cycle. Whereas in a diesel cycle, isentropic compression is same, but we uses the constant pressure heat addition process, and then the third process is isentropic expansion, and 4 to 1 is constant volume heat rejection. So in SA engine, we uses the Otto cycle principle, and in a CA engine, we uses the diesel cycle principle. Generally, SA engines are high speed and very smooth operation, and diesel engines are operating comparatively SA engines low speeds and more vibration. But SA engines initial cost is high, but the CA engines initial cost is very low. And here in the SA engines, the thermal efficiency is very low when compared with the CA engine, because in a CA engine, all particles are burning in a proper way and compared with the SA engines. So SA engines high thermal efficiency. Then in CA engines, low weight or less weight when compared with the CA engines. Then initial and maintenance cost is more in SA engine, and CA engine compared with the SA, maintenance cost is less. Generally, SA engines are used in cars, bikes, and small generators, and CA engines are used in heavy vehicles like buses, trucks, ships, rollers, and heavy machineries. And coming to the two-stroke engines and four-stroke engines. So two-stroke engines, every one power stroke is being developed in one revolution of the crankshaft. Whereas in a four-stroke engine, every two revolutions of the crankshaft, one power stroke is developed. Whereas in a two-stroke, one revolution of the crankshaft rotation, one power stroke is developed. So four-stroke engines requires a very big flywheel, but two-stroke engines require very less flywheel, because the balancing is very simple in a two-stroke engine. Balancing is difficult, so we need very big flywheel in a four-stroke engines. So lubrication, four-stroke engines, because these are the bigger engines, we need a complicated lubrication system, and two-stroke engines with simple lubrication system. The four-stroke engine design is very complicated, and two-stroke engine very simple design, and less mechanical efficiency when compared with the two-stroke engines, and more output for four-stroke engines when compared with the two-stroke engines, and less fuel consumption when compared with the two-stroke engines. So two-stroke engines require more fuel when compared with the four-stroke engines. So in four-stroke engine consists of valves mechanism. Two-stroke engines consists of a ports mechanism. Next, valve timing diagram. So valve timing diagram generally used to identify the opening and closing of valves in a four-stroke engines, and whereas in a four-stroke engine and two-stroke engines, we will analyze the opening and closing of ports. So first one is a theoretical valve timing diagram, and second one is a actual valve timing diagram of a diesel engine. So generally, inlet valve is open exactly at TDC, and it is closed exactly at BDC in a theoretical analysis. Inlet valve is opened at exactly TDC, and it is closed exactly at BDC, and exhaust valve is opened exactly at BDC, and it is closed exactly at TDC. But whereas in a actual diagram, so this is actual valve timing diagram, and this is theoretical valve timing diagram. So in theoretical, valves closing and opening exactly at TDC and BDC, but actual valve timing diagram, these valves are opening and not exactly at TDC and BDC. So inlet valve is open before TDC, because there's a strong reason for this. So the amount of air enters into the engine cylinder is more when if the inlet valve is open before TDC. And one more thing is, for proper air coming into the engine cylinder also, so this valve is open before TDC almost 25 to 30 degrees, and it is closed 30 degrees after BDC. So an exhaust valve is open 45 degrees before BDC, and it is closed almost 25 to 30 degrees after BDC. Then the fuel injection valve is open before TDC, almost 5 to 15 degrees, and it is closed 10 to 15 degrees after BDC. So for analyzing this opening and closing of your valves, we are using this valve timing diagram. So this is for diesel engine. So for petrol engine, so slightly different. Then this is the inlet valve is open 25 degrees before TDC, and inlet valve is closed 30 degrees after BDC, and exhaust valve is open almost 45 degrees before BDC, and it is closed 15 degrees after TDC. So at certain portion, valves, both valves, inlet valve and exhaust valves are both are opening. That period is called as a overlapping period. So if you observe clearly in upward stroke, so inlet valve is open before 25 degrees, and at the same time exhaust valve also opening at this period. So both valves are opening, and this is called as a valves overlapping. So that angle is almost 30 degrees. Total angle is 30 degrees. And fuel injection valve is open 5 degrees before TDC and 25 degrees after TDC. And coming to the 4-stroke petrol engine, so this one is theoretical diagram, same, and this one is actual diagram. So theoretically, inlet valve is open exactly at TDC, and it is closed exactly at BDC. And exhaust valve is open exactly at BDC, and exhaust valve is closed exactly at TDC. But in the case of actual diagram, so inlet valve is open before TDC almost 20 degrees. The only the difference is petrol engine and diesel engine. So valve's opening angle is different. So previously, if we observe clearly, inlet valve is open 25 degrees before TDC, but here almost 20 degrees before TDC. So the slight difference is there. So inlet valve is open 20 degrees before TDC, and it is closed 35 degrees after BDC. Then exhaust valve is open 35 degrees before BDC, and it is closed 10 degrees after TDC. So there is some period is called as a overlapping period. So this is called as valves overlapping. And the fuel injection spark is open almost 20 to 30 degrees before BDC, and 10 degrees after, not before TDC, before TDC, and it is closed after TDC. So with the help of this mechanism, so we will analyze the valves opening and closing exactly in an engine. Next, coming to the petrol engine. So in petrol engine, we have a ports. So there are 3 ports. So this is called as a downward stroke, and this is called as a upward stroke. So theoretically, it is opened exactly at TDC, and it is closed at exactly at BDC. But in actual diagram, in a downward stroke, exhaust port is opened initially, then transfer port is opened initially, then in upward stroke, transfer port is closed and exhaust port is closed, and inlet port is open before TDC, and it is closed after TDC. So exhaust port and transfer ports both are opened at before BDC, and these two are closed after BDC. So then the inlet port is open before TDC, and it is closed after TDC. So this angle almost 120 degrees. This angle is called as a scavenging angle. So 60 degrees after BDC and 60 degrees before BDC. So this is the inlet port is open 50 degrees before TDC, and it is closed 50 degrees after BDC. So this is called as a 50 degrees, and this is called as another 50 degrees. Next, transfer port is open 60 degrees before BDC, and it is closed 60 degrees after BDC. So this is called as a transfer port. Next one is some transfer port, 60 degrees, and this one is 60 degrees. And next one is exhaust port. So exhaust port is open 70 degrees before BDC, and 70 degrees after VDC. So this is 70 degrees and this is 70 degrees. So for analyzing these angles, so we'll draw the diagram. Then that is called as a port timing diagram. Next is indicator diagram. So indicator diagram, actually indicator is an instrument which is used to draw the actual PV diagram in an engine. Then that is called as a indicator diagram. Actually, for a petrol engine, this is the PV diagram, pressure and volume diagram. One to two, 2 to 3, 3 to 4. So 1 to 2, 2 to 3, 3 to 4, 4 to 1. So 1 to 2 is a isentropic compression. 2 to 3 is a constant volume heat addition. 3 to 4 is a isentropic expansion, and 4 to 1 is a constant volume heat rejection. Actually, theoretical diagram is looking like this. If the valves are opening it exactly at TDC and closing it exactly at PDC, vice versa also. So this diagram is looking like this. But actually, in actual case, the valves are opening and closing are different than the theoretical diagram. So that if you see the actual diagram, so these corners are round up here and here also. So here, if you observe clearly, this one is a very sharp edge because these pressure and volumes are varying like this as per theoretical analysis. But as per the actual analysis, so these corners are not a sharp edge; these corners are round off. So an actual diagram, this is the actually suction stroke. This is actually suction stroke. So suction stroke, the pressure, this is the pressure line, atmospheric pressure line. The pressure is less than the atmosphere. Then after completion of the suction stroke, then this is called as a compression stroke. So this is suction and this is compression. And next one is, this is heat addition. So heat addition takes place in a constant volume process. It happened in a fraction of seconds. Then after completion of the heat addition process, and these gases are expanding in a expansion stroke, and this is called as a exhaust stroke. So indicator diagram mainly used to analyze how the actual pressure and volumes are varying and compare with the theoretical diagram. So here, if you observe clearly, so this diagram, pressure here in a suction stroke, pressure is less than the atmosphere, and in exhaust stroke, pressure is greater than the atmosphere. So all these things are not indicating properly in a theoretical diagram. And here we observe clearly, so inlet valve is open in a suction stroke, and it is closed in after completion of the suction stroke, and exhaust valve is open at exhaust stroke, and it is closed after completion of the exhaust stroke. Then ignition takes place at constant volume at third point, and ignition is completed at fourth point. So all these things are indicated properly in this diagram. So that is the reason we are calling as a indicator diagram. Next, coming to the diesel engine. So only the difference is diesel engine PV diagram. So 1 to 2 is same isentropic compression, and 2 to 3 is constant pressure heat addition, and 3 to 4 is isentropic expansion. So this is 1 to 2, 2 to 3, 3 to 4, and 4 to 1. So in a petrol engine, 2 to 3 is constant volume heat addition, whereas in a diesel engine, 2 to 3 is constant pressure heat addition process. So thing is, this is the heat addition process. It is occurs in a constant pressure process. Previously in a petrol engine, heat addition at a constant volume, but here in a diesel engine, heat addition takes place at a constant pressure process. If you observe the actual wall time diagram, so this is the suction stroke, 1 to 2 is a suction stove. Here the pressure is less than the atmospheric pressure, and 2 to 3 is a compression stove. So this charge air is compressed in a compression stove. Then here fuel is injected with the help of fuel injector. Then ignition takes place, automatic ignition takes place. Then this is called as a constant pressure process. Then this is called as a constant pressure heat addition, this one. And this is the expansion process, and the exhaust gases are moving out into the atmosphere. So all these things are clearly observed in a indicator diagram. This is the actual PV diagram. Okay, here in the theoretical PV diagram, so this mechanism is not indicating properly. So this is for the theoretical observation only. We are using this diagram. And these are the various textbooks you can refer, Ganeshan and McGraw and references books, and these are the electronic sources. Thank you.